Alright, in this video we're going to review how to simplify radicals. So this first example, I've got the cube root of 125 x to the 9th y to the 7th. So I'm going to break down the 125. That's 25 times 5, and 25 is 5 times 5, so those are all prime. For variables, I want the exponent to be something that's divisible by 3. So 9 is already divisible by 3, so we're going to leave that. This y to the 7th, I'm going to break that up into y to the 6th, and then a leftover y. So I've got a group of 3 5s, so I'll bring a 5 outside. The cube root of x to the 9th, so remember, that's really x to the 9th divided by 3, so that's really x to the 3rd, that goes outside as well. And then I'm taking the cube root of y to the 6th, so that's y to the 6th over 3, that's y squared. And then under the radical, the cube root symbol, are all the leftovers. So the only thing that I've got left over is that single y. So that's my solution for the first problem. Second problem is the fifth root of 288 x to the 3rd y to the 2nd. So I'm going to break down that 288. That's 32 times 9. 32 is 16 times 2. 9 is 3 times 3. I keep breaking down the 16. And again, I'm looking for groups of 5. So, got a group of 5 2s, so that'll work. For the x to the 3rd and the y to the 2nd, let's make that more interesting. Let's make that x to the 13th and y to the 20th. So I'm going to think of that x to the 13th as x to the 10th, and then the leftover x to the 3rd. And then y to the 20th, that's divisible by 5, so I don't have to do anything with that. So again, I'm looking for groups of 5. I've got a group of 5 2s, so 2 goes out front. The leftover 3s will go underneath. The fifth root of x to the 10th, that's x squared, because I do the exponent divided by the index. The fifth root of y to the 20th, that's y to the 4th. So that stuff all goes outside. Underneath the fifth root, I've got the leftovers. That's 3 times 3, which is 9. The leftover x to the 3rd, and the leftover, well, that's it, because I have no y's left over. So that is a review of simplifying radicals.